Okay.
I think this is the second, gentleman.
Okay, you're on.
All right. Happy holidays are upon us. So are the dark skies and the long nights. Occasionally, our club has to cancel a star party. It's the Santa Barbara Astronomical Unit, based in Santa Barbara, California, up at our beloved home in Mission Canyon, the Santa Barbara Museum of Natural History. And this is our 251st edition of our Astronomy and Telescope Club's weekly blog, the SBAU Astro Hour. I'm your proud host, Ronnie St. McCarran, and I'll introduce some of my club colleagues on the Zoom screen in a minute. We'd love to have you join us. Just visit sbau.org online or visit us on First Fridays, attend our monthly events, yearly appearances anywhere we can set up our telescopes. This program for December 15th through the 21st, 2025, is being posted on YouTube, like all of them, and we are saving them on the website too. Here is where the cosmos takes us this week, ladies and gentlemen. We got a waning moon and a full moon arriving Friday, what some call the best of the meteor showers, as Gemini has rained down on us, peaking right now. Supposedly 100 streaks an hour or so. Good luck here. Astronomers have discovered, get this, our sun had a close shave encounter with a couple of blazing stars, but it was 4.5 billion years ago. I don't think many of us were around. Perseverance, the Mars rover, picked up, well, it's not a tornado, it's as good as they can do with the atmosphere of Mars, a dust devil. We got two views of that three-eye Atlas visitor sailing through our solar system, the cosmic comet from hell, one from ESA Jupiter-bound JUICE probe, the other from the Hubble scope. And about 15,000 satellites circle our Earth. More than half of them are from Elon. They're calling them photobombs. Now, we got lots of great pictures of nebulae and galaxies. And I just consider it a big, long, endless astrophysics course out at Royal Hall, as I invite you to meet the captain of the Starship, Commander Jerry Wilson, recently reelected. Hello, Jer.
Good morning, everybody, and good morning to my sister Joyce and my grandkids, Riley and Calvin.
And the other half of the Forgy Wilson Company that sent me that great card. I'm sure the rest of you guys got them too. Here's Chuck McPartland, Captain Outreach, our co-pilot of the Starship. His wife, Pat, also works as hard as he does. She goes out with him. She's our treasurer, merchandise manager. And I got the feeling over the weekend during the meeting that we're getting close to getting rid of everything except hopefully tote bags and cups, because I need those. And here's Tim Crawford, our navigator. There you go. Married to Karen, lens expert, and I think a great speaker. You ought to hear him on screen regale us before we go on here. Okay, Jer, we'll be joined by Bruce Murdoch, Tom Whittemore, our newsletter editor. Former Westmont science professor is not with us today, taking his car in. But we've got silly stuff we always start the show with that gets us in a great mood. I call them the president's forwarded cartoons, like this one about kitty cat owners.
There you go, Ronnie.
I'll let you read it.
Okay, G-force, a measure of acceleration that can inhibit the movement of a person under its influence.
Okay, we don't
laying down. And then the C-force.
What's that?
You cannot move because there's a cat on you. My little kitties won't get near me.
That's right. It's called the McPartland effect, on screen every so often. Here's a foursome, 3 or 4 shots of two guys lying down, and I think I got this one. One guy goes, time flies. Okay. You want to do this one, Mr. President, and explain it to us?
This is what one guy says, yeah, time flies. The other one says, yeah, when you're having a good time. And he goes, no, I mean time flies. And all of a sudden they're trying to get up and run. But apparently these little creatures distort time around here and they're caught.
Why haven't they made that into a science fiction movie? That'd be a perfect monster.
And that comes from a phrase that's often used to show how computer translation is a really tough problem because you take the phrase "time flies like an arrow," and there's
Okay.
a whole bunch of different ways you can interpret it.
Yes.
Time
We had a
flies.
grad student at UCLA that liked to do famous sayings backwards. And for this, hers was time funds when you're having flies.
Okay, here is the librarian trying to educate little Tommy. Chuck, why don't you read us through that? What's she talking
Okay,
about?
well, there's a kid with a book, and the lady says, the librarian says, instead of powering it up, you just turn the cover and get started. And instead of clicking on next page, all you do is turn it. Pretty cool, huh?
And he is awestruck.
He's
I
completely
like that one.
mystified.
Yeah.
Chemistry.
Yeah.
Christmas tree, right?
Merry chemistry.
Oh,
Yeah.
berry chemistry. All right. So any chemist would have a tree like this. Those are what the equivalent of stuff in the lab. Speaking of lab, we're going outside, aren't we? Mr. President, lead us through this one.
Astronaut hates long nightly spacewalks to ISS outhouse.
Hope it has a little crescent moon on it.
Yep,
Yeah.
there is.
And guess what? They got to go there. In Space Odyssey, it rotates, I think, at least in the rotating space thing around the Earth.
Now this is a
yeah,
reviewer.
definitely.
Let's see if I can get this right.
This was tough, man. I didn't understand any of the math. Zero.
Oh, never mind the math. It's the introduction.
Yeah.
So this, in case you fell asleep during the lecture, let's remember that. And they have this. For those who sniffed too much Elmer's glue in the second grade, don't forget that. And those who passed kindergarten may remember that it would follow. And for those who might have been dropped on their head as a child, let's remember that in which exponent is strictly what you think it is. Finally. Now, that's a play on how math textbooks and physics textbooks are written, because they always have something about remember that, and they put this expression down there. And then you're racking your brain. Do I remember that? Did I remember that? They don't show how to write that. So
Well,
this one is adding a little extra sarcasm to the.
Did you generate this, Jerry, or was this all sent to you?
No, I find these and plagiarize them.
Okay, well, so you didn't take that picture.
No.
Okay, this is a cartoon guy, I guess.
Well, yes, I did take that picture.
Oh, you did? Okay, it comes from you.
Like those guys in the Louvre that took the Mona Lisa.
Yeah.
I think Crawford and I are still long lost on a lot of that. But here's the cartoon guy lying on the couch in his shrink's office. Tim, why don't you tell me what he's saying and make your.
This one I don't get, but anyway, there's no future and nothing to look forward to in just one panel. Comic strip characters who relocate single panel cartoons.
That's right.
Yeah, there's no sequence. There's only one panel,
He's
so
not
there's no
part of a
future.
comic strip. He's just one frame.
Remember when we had the comic pages in the paper, and there were 4 of Mandrake the Magician or Little.
Usually there's multiple panels, and now there's just one. So he's
despairing it. And he's complaining to the psychiatrist.
Yeah,
Okay,
yeah.
I get you.
Well, that doesn't. Okay,
this was very striking. It's not a cartoon, of course, but from Noam Chomsky, truth has never hidden from humanity. Humanity hid from the truth. And from Bertolt Brecht, people do not fear lies, they fear truths that demand transformation.
Whoa.
In the German club, I was in the German play one year, and we did Trommeln in der Nacht, Drums in the Night by Bertolt Brecht.
You were in the play?
I was in the play, yeah, I was a soldier.
Who staged the play and when? You were young,
The German club did at Cal State Northridge.
Oh, and which one of these 2 gentlemen wrote it?
Brecht. Bertolt Brecht.
Well, it sort of applies today, doesn't it? All of that.
There's something that I read by him. Can you tell me a couple of different plays he had?
I can't anymore.
Okay.
It take too long to come to me.
No, there was something I read by him.
Yes, he's written a lot of stuff.
I wrote down one, Mother Courage and Her Children was a play by him.
Huh.
I don't know what that means, but it certainly thought-provoking. Gets us to the night sky, ladies and gentlemen. Brace yourself. Please buckle up.
Okay, this is the night sky at 3 a.m. Tonight. No, this is the 15th, so this would be tomorrow morning, a.m. I was going to put this morning because it'll be the same, but I'd get accused of looking at something well, it's already passed. So this is the radiant of the Gemini meteor shower. So if you want to see meteors, don't look here because they'll just be a little momentary bright flash. You got to look about this far away in a ring. That's where the things are shooting away, so they have a little lateral extent, and you see them around there. So anytime between midnight and 6 a.m., you're on the front side of the Earth, and it's just analogous to your car going through a rainstorm. You see the raindrops hitting the windshield, but they do not hit the back of the car's window because you're running into the raindrops. The Earth is running into the meteors, so you see a lot more on the leading edge when you're looking out the windshield of the Earth in its orbit.
And the peak of this shower was actually Saturday night, Sunday morning. So we had clouds, of course.
Yeah.
And last night I was out around 11 p.m. For an asteroid and in a nice dark sky, and I did see one Geminid, but it was over in Pisces,
Okay.
so way over on the other side of the sky.
A traitor.
Yeah.
So anyway, I'm showing that tonight because this is it did peak, as Chuck said, Friday and Saturday, but it's a broad shower. You will get Gemini. It's probably a decreasing probability this week. So chances are good. It's quite a prolific shower.
Are meteors something the whole Earth sees? The same ones?
No, if you take they're in our atmosphere. So it's like an airplane. You look up and you see an airplane. In Europe, they don't see the same airplane.
But all parts of the Earth, as it turns during the week or however many days, would see some of the Geminids, wouldn't they?
Yeah, they will see Geminids,
Yeah.
But not the same Geminid we see here.
And they might not see the peak if it's a sharp peak.
Yeah, but it's not for this one.
Jerry's talking point said over 100 an hour sometimes, but I doubt we see that many here.
There was, according to space weather, there was 120 an hour on Saturday night, Sunday morning, and now it's down to about half that.
Oh. Well, next Friday, this coming Friday, we might have a few, right?
Yeah.
It's going to be pretty well petered out by next Friday.
By the way, the Bertolt Brecht that I remembered, it was Galileo. I was in a physics class, and his play on Galileo, the guy said, "You'll get an A if you just read the play." What an idiot! I stayed with the physics and ate it, and then all I had to do was read the book. But it was for the best.
Was it Galileo versus the church, or Galileo?
It was just a play on Galileo, his life. So
a lot of not many notes are taken on Galileo's life when he was alive. So any play on him is going to have a lot of poetic license.
Yep.
So anyway, this is a picture of the 2023, I believe. Yeah, 2023 Gemini shower.
Wow.
I don't know exactly where it's taken from, but this is many shots. It's not one frame. They were probably
composited.
Yeah, a number of subframes were added together to get this shot.
And Castor and Pollux are right there in the middle.
Yep.
Oh, interesting.
But you guys can't get pictures like this with the camera attachments to your scopes. You got it disconnected, don't you?
No, you could.
Well, you can't get a wide field like this.
Yeah,
exactly. It's so they just hold the camera up and leave it open.
Yeah, it's sitting on a tripod. There's no blurring in the landscape, so the camera didn't move.
Got it. And they are coming right at us, aren't they, from that radiant?
So when you say you take a picture, say you're up at 1 o'clock and you take pictures till 4 o'clock, the sky is of course moving. But when you register these, you move the pattern of the stars so that the stars line up, and then you compress it with the landscape. So you get a simple picture like this. It's very similar to these pictures that you see of a comet with all this structure in the tail where the comet has been stacked with subframes, but the stars are not streaked. That's not an easy picture to make. It will be the subject of my article in the newsletter in a few days, 5 days.
You know something Neil deGrasse Tyson does is criticize science fiction movies for stuff that isn't believable. And something he's never noticed that I notice, when the Millennium Falcon hits warp speed, all the stars sail past him.
Yes.
All of them look like what we're seeing here, which is impossible. You can never go that fast.
It's also wrong because for another reason, and that is that at light speed, all of the scenery that's going by, it all compresses into the front. So it contracts into the front because of what does that call that? Aberration?
That's the speed of
There's a word
light,
like
you
that.
mean.
Yeah, photon aberration. But it all appears to be focusing in the front.
Well, wouldn't there be a photon compression?
Oh, no, that's not the word. There's a word for it. And
Okay.
it escapes me at the moment. Increasing number of words are doing that to me lately.
Huh. And this would be at the speed of light, right?
That would be you can't go at the speed of light, but as you approach the speed of light, the view of the outside world compresses to be in front of you.
But then it gets very, very slow.
Because you're running into the light, just like the Earth runs into meteors.
You know, Albert Einstein discovered all of that, didn't he? Over 100 years ago.
His math discovered it. Other people got into the math. And one of the famous ones that I like about that is the Georges Lemaitre, the Catholic priest. He went through Einstein's equation, and then I don't know how he communicated. I think he wrote a letter to Einstein and he said, I went through your equations and your equations predict a day that had no yesterday.
Whoa.
And Einstein didn't like that because he likes a perpetual steady state universe.
Well,
so he had to go add lambda.
Was it Galileo that tried to measure the speed of light by having a guy on another mountain turn his lantern on the minute he saw Galileo's go on, but they both realized it was too fast.
Yeah, that's measuring the speed of light in our reference frame, not in light.
No, it didn't work. But I was wondering if it was Galileo or Da Vinci.
Oh, no, it was much more recent than that. It was like no, not Maxwell. It was the guy that did the ether experiment.
No, but Ronnie's right. There was in ancient times there were people experimenting like that.
Yeah, they had good ideas.
Well, there's some stuff on PBS about these guys. I just get swept up in it for hours at a time. Da Vinci and his painting and his inventions. My God. As well as
are you thinking of Michelson, Morley, something like that? That when they
that's who I was thinking of.
Okay.
But many people have tried it over time.
Well, at least Ole Romer got something out of it.
Yeah. Okay, this is a schematic of our sun's motion, direction of the sun traveling through a local cloud with Alpha Centauri's Ceres. There's another star. No, I guess there's no other star that's identified in here. But about 4.4 million years ago, we came as close as 30 light years to our star, to some of these other stars. Of course, Alpha Centauri is like 4 light years away right now, but on astronomical scale, 30 is still pretty close. And these have changed the motion of our star in the Milky Way.
They were big stars, right?
They were big hot stars, and their radiation has left effects on Earth. And that's the point of this.
Do we know where they are now? Do they have names? Do we see
Yes.
them in the night sky?
Yes, just a second. I didn't highlight what my eye cues or cues.
Adhera and Mirzam. So
Yeah,
two of the legs of Canis Major, the big dog.
Yeah, I knew there was something that I remembered about that. You're right, Chuck. That was them.
And
I knew
so,
Atara, not the other one.
so astronomers are tracking the way they're going, and they figured out that they came from here, from
That they pass by, yes.
nearby us. Okay. Were they orbiting? How did
No,
they
they
get
just passed by. They're orbiting the center of the galaxy.
I know, but how close were they to each other?
Oh, they weren't close to each other.
Oh, but both of them came within 30 light years.
Yeah.
So we were doing, relative to those stars, we were doing 58,000 miles per hour.
Hmm.
And we are living apparently in a hot local bubble. Also, I'm sure you've heard that before too. Oops. And usually I go back and I fill the text with bold letter statements so I can pick those out by eye, but I neglected to do that in here. So anyway, this is an artist's rendition of our local bubble that we live in. It's devoid of gas and dust in the Milky Way, in which the sun sits.
I have an X-ray of my teeth at the dentist. It looks just like this.
Very much like that, yeah. So,
There's some
this-
plaque.
yeah, I don't have a scale for this. I don't know where Alpha Centauri is. There's all these structures here, which were not identified.
Now, Jerry, am I to kind of assume that this bubble kind of protected us from outside influences?
That's the claim here. The fact that the sun sets inside of a set of clouds that can shield us from ionizing radiation may be an important piece of what makes Earth habitable today. The professor explained. So they're doing modeling of this to find out exactly where it is and how it happens.
Boy, talk about a Goldilocks zone.
Yeah, I'm not sure I believe this. I don't know where our Oort cloud is with respect to this.
Mm.
It would be small because this bubble is huge.
It should be, but then we should see Alpha Centauri or something in it too.
Well, you know, artist rendition.
Yeah.
So more on that to come.
So the Voyagers are both still in that bubble with us.
Oh, way inside, yeah.
Okay.
Yeah.
Here's the Dust Devil from hell.
There you go, Ronnie.
It's a little washed out.
A little washed out?
Yeah.
I'd like to see this without this was, I didn't blow this up. I wanted to see it.
Looks fine to me.
That's pretty cool.
Yeah, the detail in the Dust Devil's really blown out in this one.
And Ronnie, you know that one of the rovers on Mars, it stopped performing, and one of these dust devils went by and it blew the dust off the solar panels, and so it started working again.
Yeah, it hadn't totally died, but the power levels had gone way down and they were worried about it.
Yeah.
I wonder if it's Curiosity you're talking about. One of our future speakers in 3 months is going to she's
No.
an expert.
Curiosity is run by an RTG. It's got a nuclear power source because of that.
Okay.
It was one of the original Spirit and Opportunity ones.
Yeah, it was one of the first ones.
Okay, well.
Okay, I managed to lock myself out.
You know what? Why do we have dust devils on Mars? Are there that many atmospheric conditions with one?
I'm going to shut down the meeting and then rejoin.
Okay, Jerry.
Well, there's wind, Ronnie.
Wind?
Yeah.
It's 1%. How can they have? Okay. What is their atmosphere? It is not a lot of oxygen, is there?
Carbon dioxide.
It's all CO2, pretty much.
And that's one of the complaints about the book and the movie The Martian, when they have a windstorm and it damages the habitat and all, is that it just wouldn't be exerting that much pressure. So he had a little artistic license at the beginning to set up the story.
That's
Well,
interesting, Jerry. There's two of you.
Yeah.
There are.
Yeah.
One's looking one way and one's looking the other way.
how did you do that, Jerry, Mr. Prez?
He shut down, but he's gotta clear out the other one.
Oh,
There it is.
Oh, there it goes.
Okay.
You got it.
Zoom is doing its thing
In
again.
control again.
No, it's not Zoom, it's me.
Oh, it's you. Okay, well, we'll blame you then. But you're back.
Yes.
You got your little flip phone from the original Star Trek series and got beamed back up to our.
There's a lot going on. I wouldn't be able to do this stuff that he does.
Let us see. Yeah, I'm not so sure I'm doing it here. Okay. Gotta go down here, get this. Gotta go down and get, oh, that's right. We're out here because of the paleness of that.
One of Neil deGrasse Tyson's criticisms was of the Martians, the movie, because he couldn't have grown potatoes in the soil of Mars.
Yeah, he could have. He could have.
You think so?
Yeah.
Not dirt. It's not dirt.
Yeah, it is. It's
Dirt is
regolith.
living. Dirt's got life like you wouldn't believe. I would think that.
That's why he had to use the leftover samples of what we produce.
Oh, I see. Okay, the fertilizer that he made
Can you
himself.
see
Yeah.
this?
Yep.
Yes, now there's a lot more
Jerry.
detail in the Dust Devil.
Yeah.
A little smaller though.
It's pretty cool.
Okay.
So let's stop that because it's too successful.
Yeah, just go back. It was pretty good the other way, Jerry. It's much easier
Okay.
for you to do that.
But that's pretty much the extent of the extreme weather on Mars. They don't have storm. It doesn't have storms, does it?
It has huge dust storms that cover the
Yes.
entire planet.
Wow. Science should be studying how that happens. What
They
Well,
do.
that happens when the carbon dioxide ice pack turns into gas. And so you got this rushing of their air of carbon dioxide throughout the atmosphere.
But is there a disparity in temperatures like on Earth?
Yeah.
Warm water versus cold air from the north, and suddenly, is it
Yeah.
far
Yeah, and
apart?
that's what fires off these dust devils too, is patches of colder air.
Chuck,
And warmer patches of warmer air mainly.
Got it.
the last I heard, Chuck, I mean, there was so much ambition to put people up there to live on Mars, but there's a lot of things that are now being talked about that makes that pretty unlikely.
It's pretty tough.
Yeah,
Radiation.
it's not going to be easy.
Yeah, you got to be a gopher.
Yeah, radiation alone.
What is it? Was it Heinlein that wrote he wrote a novel on the body being completely changed by living on Mars for a long
Mhm.
time. And then coming home again would be almost impossible.
hmm
Bones of brick.
Even Andy Weir, who wrote The Martian, wrote Artemis about colonies on the moon.
Yes.
A similar thing would happen to people that have been living on the moon. Okay, here we have a live dust devil.
Oh, wow. Ooh.
A whole
Boy.
bunch of them all over the place.
Yeah. Boy, they get around, don't they?
Yeah.
Yeah, they clean off the solar cells if you're lucky.
Yeah, exactly. Exactly.
Driving home from RTMC through the desert route one year, there was a big dust devil in one of those areas where it's kind of desolate.
Uh-huh.
And there was a huge piece of plywood flying around at high speed. And I was
Ooh.
just hoping it didn't work its way over to the highway.
Oh, yeah.
When I was on the ship eons ago, Chuck, there was a water spout.
Mm.
The water spout and us were getting really close together. I think we just touched the edge of its influence. That was pretty interesting.
Now we have them off our coast here.
Yeah.
This is a picture of 3I Atlas. It's taken from the JUICE spacecraft.
Ah, which is launched by ESA, European, right?
Yeah.
Yeah.
Out of South Africa or South America, rather.
Yeah.
Now this is the spacecraft's orbit. There's Mercury, Venus, the Earth, and Mars. The comet, when this picture was taken, the spacecraft was right here, and the comet was just inside the orbit of Mars. So about 40 million miles away, 43 million, as I recall. And this is the best they do. Now you'll notice all the portholes are closed on that side of the comet. So anyway, we get a plasma tail and we get a potential dust tail here, but no detail on the head. You can't see the head inside the coma. The exact size of the asteroid is still, or the meteor, the comet, is still in doubt.
Huh. Well, this appears to be the third visitor, if you count Oumuamua, but God knows we must be finding far more.
We will, and we have, but in our time, they're quite rare. So
Yeah, the instrumentation, you know, the equipment just got good enough to start finding these things.
yeah. So and here, this is a Hubble Space Telescope of 3I Atlas, about the same time that JUICE took it. Now, the Hubble is about 400 miles in orbit around the Earth, so it's much closer to the Earth. It's much farther away than JUICE is, but of course, it's got much better optics and a bigger telescope. It's stacked to get the comet image right, and so the stars trail. But
right.
It's got suggestions of the dust tail here. So I think
and it's getting the green glow.
Yeah.
Assuming this is an attempted visual colors here.
That's the tricky thing. There was a class I took at an advanced imaging conference about how to take Hubble Space Telescope images and make them look like an amateur telescope astro imager would make it look, because we base it in astro imaging in the hobby. We make it red, blue, green, like the human eye would take, and roughly in the sensitivity range that mimics the eye. But Hubble doesn't have those filters available to it. So you have to take what they have available and you have to approximate what the processor thinks would be like red, blue, green. And this is like that. These are all false colors. All astro pictures are false colors. They're not the way it really looks, especially the infrared ones. You can't even see infrared. So, but it does.
All our regular comets would look just like this if we just left the lens open a long time.
Well, no, they show different amounts of detail in them. This one's quite far away, so we don't get a lot of detail. So a lot of comets do look like this at this distance.
But this is 3I Atlas.
Yeah.
Mm-hmm.
Okay.
We even have some spacecraft images from being on the comet's surface.
Yeah. That's the European Space Agency.
Yeah,
again.
not this comet.
Yeah.
Now, these are a quick sampling of 8 photobombs in space. That is something that jumped into your field of view that you weren't after. And these are taken by the Hubble Space Telescope. And all these are streaks produced by artificial satellites that just zip by the field of view. Now, when it's just a thing like this, even here with 4 of them, if you take a stack of images, and this only occurs on one of the substacks, they're very easy to eliminate. So they're not a problem. But the point of this, having them here, is apparently they're going to be a problem.
Yeah. And the Hubble Space Telescope has a teeny, teeny, tiny field of view.
Right.
So it's crowded up there now.
Yeah. Things like the Roman telescope is with very wide field of view is going to have a very different story. Lots of streaks to eliminate.
Even people who are trying to take pictures of some of these recent comets when they were low in the morning or evening sky, that's when also these Starlink satellites get illuminated.
Yes.
And there were just huge crisscross patterns all over the images.
But the reason we're seeing them as a streak is that the sunlight is somehow hitting them.
Yeah.
Yeah. Yeah. Just
Okay,
like we see
otherwise,
everything, sunlight has to hit it, except a
okay.
star.
Yeah.
So when we see the ISS go over the museum, there's still enough sunlight at 9 o'clock at night.
Well, it depends on the time of year. In the summer at 9 o'clock at night, the sun's still shining on them.
I guess that's when we saw it, right?
But you can see the ISS go across part of the sky, and then all of a sudden, bip, it's gone,
Yeah.
passed into the Earth's shadow.
And there are apps that can tell us which one are hitting us, Chinese, American.
Yeah.
Who else has a space station up there?
Well,
Japanese?
there was almost going to be a Russian on the last launch, but he was caught taking pictures of things he shouldn't have been taking pictures of, so he was sent home.
Oh, really?
Yeah.
Well, I thought that's why half the satellites are up there.
Yeah, but the International Space Station is supposed to be non-military use.
Oh, I got
But
it.
but around the buildings and the labs on the ground, apparently there's restrictions.
We
So this,
we visited the Soviet Union, my mother and I,
Mhm.
back in 1975, and basically the instruction was you do not take any panoramic views of a city. You do not take any views of power stations. You do not take any views of dams. You do not take, no infrastructure pictures allowed. So you're
Uh-huh.
basically limited to statues and single buildings and people.
How about Red Square in front of the Kremlin?
Yeah, you could do that.
You can.
Yeah.
Okay. Guess there's nothing secret there. That's all right out there. Domes,
Yeah,
dome
lots of
top.
onion domes, but you had
No
to make
onion
sure there
domes
was
are
no,
Onions.
yeah,
motorcade coming by.
they're far out. Well, what
Okay,
does
here we're gonna shift now because we have an advantage this week. We're coming into a new moon, which means no moon. And so we want to take advantage of looking at some faint things. And one of the brightest faint things is M33, the Triangulum Nebula. It's about half the size of the Milky Way. Now, the constellation of Triangulum is right there. And this is the star Merak in Andromeda. This is the border between Andromeda and Triangulum. And right here, just over the border, out of Pisces, but in Triangulum, is M33, the Pinwheel Galaxy, but I call it the Triangulum Galaxy.
Because there's another pinwheel, 102,
101, I think.
101, yeah.
And then there's the Whirlpool Galaxy, which is M51. But this is Andromeda Galaxy down here, which is twice as big. They're both very bright, and they are each individual objects that you can see with the naked eye on a very dark night from a very clear site, like a mountaintop or something. And so this is the Andromeda Galaxy. Merak, that star, is right halfway between the two. So it's a way to get there. You start off to the right and you go from Polaris right through the middle of Cassiopeia and you come to Merak, then up and down to get to these two galaxies.
would the Magellanic Clouds be in there somewhere?
No, that's the southern hemisphere, Ronnie.
Oh, that's but part of the local group. So they're all around us. They're not concentrated around Andromeda or in the same part of the sky, in other words.
Yeah,
I'm
the large and small Magellanic Clouds are satellites of the Milky Way. They're part of they're part of the local group because of that, but these are big local group galaxies
yeah,
here.
the Andromeda Galaxy is 8 full moons across.
Wow.
So it's big.
And M110 and M32 correspond to the large and small Magellanic Clouds in our galaxy.
Yeah.
But is local group just us and our orbiting
No,
galaxy?
no, it's
Satellite?
Andromeda and
All
M33
local
and
group.
Yeah, there's quite a number of them. Now, this is that region again, but without the, this is a photograph. That was a planetarium construction. And here is M33. Here's Merak. This is upside down from that one. And there's M33. Shows the major stars around it. And it shows them in their colors: Almach, Deltotum, Gamma Trianguli, Mothala, or Mothra as I mispronounce it, Hamel, Sheraton, Mesartum, and of course Merak with M31 and M33. And the this blurb is out of the text, but we don't usually show the text. But the future of the Triangulum galaxy cannot be predicted with any certainty, but it is tied to that of Andromeda galaxy, of the Andromeda galaxy and the Milky Way. M33 will either be absorbed by Andromeda in about 5 billion years, like we will. It will be part of Andromeda's collision with the Milky Way. It will collide with the Milky Way itself before Andromeda does, or be ejected out of the local group of galaxies. The Triangulum galaxy is currently approaching the solar system at 179 kilometers per second and approaching the Milky Way at 24 kilometers per second. The difference in these two speeds is that we're whipping around the center of the Milky Way and right now heading towards the Triangulum galaxy at the speed we're doing in the Milky Way. So the reason that this is so difficult to have, I'll pick between these options, is the speed directly toward us we can measure very accurately by looking at spectral lines, and we see whether it's red shifted or blue shifted, and that gives us that speed. But in order to get its sideways speed accurately, we have to wait till it actually moves sideways, and that's going to be a heck of a long time.
Yeah. And that's a little confusing because the solar apex, the direction we're going around our galaxy, is towards towards Hercules.
Yes, but a component is heading toward Triangulum.
Yeah.
So this is an amateur picture of the Triangulum galaxy. Here is a very large star forming region called, it has its own number, NGC 604. And this is a picture I took from my backyard.
Wow. Nice, Jerry.
Thanks.
That bright spot is not a star in our galaxy?
Not the bright red one.
Things with diffraction spikes are stars in our galaxy.
Oh. Okay,
This thing down here, that's a feature in M33. You can see clouds going off around here.
So they're mini spirals, aren't they? Do I count two arms? Two major arms?
Yes, this has two basic arms. It's a simple spiral. It's not a barred spiral, it's a core spiral.
Okay.
And it's face on, Ronnie. So in a telescope like what I have, it's really dim, but it's really big. I'm curious what the little sea stars would see in this.
Yeah. Now this one was taken with a 4-inch aperture teleview refractor. So
really, and you still have the diffraction spikes? Did you put a mask on it?
Oh no, you're right. That can't be a refractor. This must be I took it with my 10-inch reflector then. But I was guessing because of the wide field.
Uh-huh.
But where
does the triangle where does the triangle come in?
That's the constellation it's in.
Yeah, it's way bigger than this picture.
Okay, but is it three-sided? Is that the reason?
Yes.
Okay.
Here it is.
Here's Triangulum.
Okay.
And here's the pinwheel, M33.
But what are the 3 points that make the triangle? What are
they? This stars. Alpha,
they're stars,
Beta, and Gamma.
It's a constellation, Ronnie. Those are stars.
Okay, I understand that, but they found a smaller galaxy behind it, and they just gave it the name Triangulum.
Because it's in the constellation Triangulum.
See, it's within this border region. So it's
there it is. Yeah, That's what Ronnie's asking about.
Yeah,
And that's the
everything
same reason
inside
the
the star.
Andromeda Galaxy is called the Andromeda Galaxy.
So the constellations came first, and
Yeah.
then we discovered the galaxies. We
I
took
think
them.
these constellations were settled in the 1920s, I think. Wasn't that about it?
When they officially became that, but
Yeah,
Andromeda is an ancient constellation.
yeah.
Huh,
Okay. Now
fascinating.
this is another picture of M33 taken with a larger telescope. This was taken by Adam Bloch with a 26-inch Dalkirkham or corrected Dalkirkham at Mount Lemmon Observatory. And here you can see a higher resolution view of NGC 604 up here. You can see all these dark lanes of Barnard type nebulas. And these red regions are all hydrogen alpha, where star formation is taking place.
Hmm.
It's a beautiful galaxy.
About
All this
half
stuff
our
is
size.
not visible to the human eye, naked eye.
Would that image right there, Jerry, would a C star, the 50, see something like that, or would it
No,
be
this is a 26-inch diameter telescope.
okay?
Now, this is a picture of the core mosaic taken by let me just check.
Hubble.
Yeah. Oh, yes.
The core, it's not a bar.
It's a composite of 54 different pointings with Hubble's Advanced Telescope Survey. It was taken in 2015. Not that there's been any change, but you can actually pick out individual stars in M33 here. And this is that picture, and it shows the serrations due to each Hubble images that was put together to make this mosaic. And it's pasted on a larger field of view picture taken from an Earth-based picture from an Earth-based telescope.
And that background one is a little bit more like what your sea star might get.
Yes, that's about right. Yeah.
Okay, thank you. That's what I was wondering. So that's a huge advantage
Yeah.
for those C stars.
This is a magnitude 6 galaxy total with all the light added together, but it's spread over a fairly large region, about a
Yeah.
full moon or 2 full moons. So you're going to have quite a big object in there. Those little C stars are going to be a great thing to take pictures of it.
Exactly, because when I get in my scope, it's so dim. It's
Yeah.
huge, but very dim.
Do you suppose there's a supermassive back in the middle of that?
Oh
No,
yeah,
turns
probably.
out there's none.
There's none.
Oh, really?
This is a picture of this is an artist's rendition of a very hot blue star near a black hole, a stellar-sized black hole in the M33. And this is an X-ray picture, X-ray and optical superimposed of that same thing.
Huh.
It's got quite a caption on it.
It
Looks
does
like
have a central black hole, Tim, but it's not supermassive.
That's right. That's right.
Okay.
looks like a sparkling diamond at K Jewelers.
Yeah.
The black hole is it's a stellar mass black hole. It's fed by debris from the blue-white star, from the blue companion star.
Wow.
And it's swept into orbit around the black hole, and it creates this disk. But this is not the central black hole in the core. This is just one in there in the galaxy. We have a large number of them, I think 30 some that we've identified in the Milky Way that are stellar-sized black holes that are just
Wow.
floating around.
And it's 70 solar masses for that big blue one. That's going to blow soon.
Yes.
Oh,
Huh.
I mean, relatively speaking.
Yeah. Yeah. It'll be after midnight.
Yeah.
Jerry, yesterday, Tom Totten was in the pit, and I was telling people, as a guest there, that Tom Totten has a way of clowning with people, and some people, he'll talk about Beetlejuice as going off at midnight, and
Yeah,
the looks on their
after
face.
midnight.
After midnight, yeah.
Okay, this is a close-up. This shows a black and white picture of NGC of the M33.
Good grief.
I don't pick out the telescope name from this logo, but STSI might be Hubble. But anyway, it
That's a
shows,
Space Telescope Science Group.
yeah, the group, but I don't know that it was necessarily Hubble.
Yeah.
But here is the NGC 604, and here's a close-up view of NGC 604. And this
Actually,
is,
up top it says Palomar, so that must be a
oh
Palomar
yes,
scope
right,
image. Yeah.
200-inch, yeah.
Yeah.
Good spot. That's the problem with some pictures. They hide the information in plain sight pretty quick.
But those two pictures are the same galaxy?
No, this little square is this square. So this
Oh, I
is
see.
that.
Got it.
I wonder what the Hubble shot that in. Is that infrared or
No,
Hubble can't
doesn't
do infrared.
oh,
Yeah, it does NIR, near infrared and visible.
So is that a nebula in the galaxy?
Yes.
Yes, it's a star-forming nebula like the Orion Nebula, except it's bigger than the Orion Nebula.
Hugely bigger. And that's the NGC 604 we've been talking about since the beginning of this little bit.
Right.
Right. Okay. And so all the lit up areas are heavy new star formation, I guess.
Yeah.
The
wow.
colored areas are different elements, hydrogen, oxygen.
Yes.
This is,
But in this palette, it's not the usual one you'd expect.
yeah, this is 1,500 light years across. Over 200 newly formed hot massive stars have been discovered in this breeding ground or this nursery.
Huh.
So to give that size relative to things you might be familiar with, this nebula would stretch from the Orion Nebula all the way to us.
Mhm.
Ooh.
Now it says here it's 100 times larger than the Orion Nebula.
Makes sense. What's the name of it?
NGC 604.
Well, they just gave it one of those.
And this is a Hubble picture of it.
And you can really see the cluster of stars in the middle there.
Yes.
God,
And
man,
they're
that's amazing.
They're full-fledged adult stars, and you can see they're doing their magic of blowing the dust away. It's starting to hollow out cavities in here. And at some point, it will blow all the dust away, and it'll just be a large star cluster.
It's just like I see it in my little telescope, Ronnie.
Now, this is the same thing in X-rays.
Whoa.
So this is the largest star-forming region in M33.
Well, at the risk of going over something we may have covered before that I forgot, could this become a future star cluster, globular?
Yep, it's in progress.
And the blue puffy things, that would be the gases of a certain type.
That's X-ray.
Yeah.
X-ray emission from hot gas.
Yeah. Remember, this
From hot gas,
color.
okay.
They just pick a color that is easy to spot, and they make whatever they like, they make it that color.
Wow.
It's interesting. Down at the bottom of my screen, it shows we still have 5 participants. Oh, there's Bruce.
Yeah, I did a useless trip down to the Arlington.
Oh, hi, Bruce.
Hello.
Useless trip where?
The Arlington is put on at the Arlington Theater once a year, and the whole front of the stage has to be opened up, and the organ console has to be removed.
Oh,
And they wanted us back down there today at 10 o'clock to reinstall everything. We get down there, there's nobody there, the stage is clear, the organ's already back down in the pit, and it was a Chinese fire drill.
get no respect there, do you, for the Theater
No.
Organ Society?
No.
Bruce Murdoch, everybody joining us, one of our big club members.
Hello.
This is a picture of Triangulum Galaxy in infrared taken by the Spitzer Space Telescope. It shows the regions of star formation, the hot hydrogen alpha stuff.
Looks kind of like the Crab Nebula.
Yeah.
Except it's
Wow.
turning the other way.
Fascinating stuff.
Yep. And that concludes our show.
Well,
Oh,
except
all
for
right.
one
Hello, goodbye.
Can I form a question?
Of course,
I'm trying to think of what they call the distance between photons depending on the frequency. What is that called?
the wavelength.
Wavelength. What are the wavelengths in X-rays? Are they minuscule or are they still miles and miles apart?
No, they're tiny, tiny.
Yeah.
Tiny. They're beyond ultraviolet.
So the frequency of X-rays and gamma rays is just incredible, isn't it?
Yeah.
Very high.
It's about an angstrom.
How in the world do they get enough photons to fill that?
The number of photons doesn't matter. It's how much energy each photon has. You can have a lot of energetic photons or very few energetic photons, depending on your source.
That wavelength, Ronnie, is like each photon is like a little packet of waves. And that wavelength is is the wavelength that's in that packet. And then when you have more photons, you have more packets going by you.
Packets.
But the energy is the same. It's just the volume is different, bigger.
Bullets.
Telling me
Packets of
Bullets.
bullets.
Yeah, you have
Bullets that
50
look-
caliber bullets, and how troublesome it is depends on how many of those are flying by you.
A machine gun. The energy of a photon is E equals h nu. H is Planck's constant, and nu is the frequency. So as you
Or
go
a
up in,
wildebeest.
And somehow in a dentist office, they have a machine that can generate that.
Yep.
Yeah.
What do you suppose it is? It's not a
It's
crystal.
You know, when you had an old-fashioned TV with a cathode ray tube and the electrons, an electron gun in back, and the electrons were fired straight at the front of the screen and they hit a phosphor on the inside of the glass. And when they stop, an X-ray keeps going. That's how you produce X-rays. That's why they told little kids not to sit with your face too close to the screen.
but also the front glass on those tubes was had a lot of lead in it.
Yeah.
To try to reduce that.
But that had nothing to do with production of X-rays. That just helped cut them down for safety.
Absorption of X-rays.
Are the modern TVs dangerous?
Are what?
Are the modern TVs dangerous for
Oh,
little
probably
kids?
if you get hit over the head with one.
Or you eat the materials.
Yeah.
The reason I'm saying is our little kiddies like to watch football about 2 inches from the screen.
That's because the screens are so good. They have detail now and it gets the cat's interest.
Oh God.
Old TVs were too blurry for the cat to be turned on by anything it saw.
We had to turn it off, man. We couldn't get them away from it.
Mhm.
Well, now you know how to keep them entertained if you need to go away for the day.
Yeah, Joe. Well, there is a cat TV, and they're dangerous because they have little birds flying by,
Yeah.
and animals,
Oh, yeah.
and boy, they'll knock it down.
Yeah.
There are tons of YouTube videos too for entertaining your cat.
Is that right?
Yeah.
Yeah.
One playing the piano.
Well, no, for entertaining your cat. They show mice running around and birds chirping.
Right. You just show a mouse and the cat just is going nuts. Where I'll get it.
Okay, I have a quick question that's off topic. As you know, I watch that, how the universe works now and then, and they were talking about planetaries and how our sun will eventually become a planetary. And, the star shrinks up and becomes a little white dwarf in the middle. And then they were talking, this I didn't know. They were saying that the white dwarfs don't emit like a heat.
Sure they do.
They're very hot though.
Yeah.
Well, they were saying that they eventually turn into a dark planetary.
They're just radiating away the accumulated heat that they have, which is quite a bit. So over trillions of years, they will gradually cool off and become like a lump of charcoal.
Yeah.
And they said they become a dark dwarf.
Yeah, they call them, instead of white dwarf, a black dwarf.
Yeah, black dwarf.
Yeah.
And that's interesting. I've never heard that.
Tim, it's exactly analogous to a blacksmith that's got a piece of iron in the fire, and he's using the billows to make the fire real hot. And he pulls the piece of iron out of the fire, and it's white hot. Okay.
Yes.
And
Yeah.
then he puts it down on the bench, and if it doesn't burn the bench up, then it slowly cools down and becomes a room temperature black piece of iron.
Yeah.
Exactly the same. There's no fusion going on inside the iron to make it glow when it was white hot. It's just heat.
Now,
And
is it possible that these little black dwarfs collectively could become like dark matter?
There
no,
hasn't been enough time in the existence of the universe for a white dwarf to become a black dwarf yet.
Right.
Really? Whoa.
Back in
Yeah.
the 1800s, a thermodynamic physicist named
Eddington.
Boltzmann,
Oh,
maybe
oh.
Eddington was in the 1900s.
I thought you were talking about the sun, if it was made out of coal, how long it would last.
Oh, it's the same calculation.
Yeah.
But Boltzmann estimated the age of the sun. Oh no, excuse me. He estimated the age of the Earth by estimating that it started as a lump of molten rock, and then it cooled down to the present temperature it's at. And he counted for the sunlight and stuff. And he got an age that was way too young, but he did the math right and he did the physics right. He just didn't know that there were radioactive materials in existence, and some of them were in the earth and now were a heat source. And if he included that, he would have got the age of the Earth right.
Whoa.
Yeah,
That's
Eddington
neat.
did that too. That's a famous calculation. Every student of thermodynamics is going to run through that calculation.
I think you should put this on a future talking point. We'll kick it around next week or sometime in the future, Mr. Perez. What's coming up outreach, Chuck?
Wednesday night is Goleta Valley Junior High, and then Friday is Westmont, and then we're done for the year.
Well, gentlemen, we've reached the end. It was just great to break bread with you. Some of you last Thursday at our December holiday party out at Goleta's Hilton, as well as to break our white elephant exchange gifts right after we got them. You had to have been there, folks. Things are happening. Join us, and it is time for our special SBAU farewell. It's done this way. Chuck?